Properties of sigma, as well as the special sums, will allow us to compute the values of sums for certain sequences. The properties and special sums are listed on the right. In this example, we want to find the value of the first 125 terms of the sequence 2k plus 1 squared. If we look at this form of that sigma, you can see that we are adding terms that are the squares of the expression 2k plus 1. If you look at the properties or formulas, you notice that there is no property that will allow us to deal with the product of sequences. And here we have 2k plus 1 times 2k plus 1. Therefore, to use the properties, we have to rewrite this sequence as the sum, because then we can use the property that sigma of the sum of two sequences is the sum of sigmas. So we can square the expression 2k plus 1 and we'll get sum from k equal 1 to 125, and 2k plus 1 squared is 4k squared plus 4k plus 1. Now within sigma we have the sum of the sequences, and therefore we can use the mentioned property. Right here we can, so to speak, distribute sigma over each term. So this is going to be sigma from k equal 1 to 125 of 4k squared plus the sigma from k equal 1 to 125 4k plus sigma from k equal 1 to 125 of 1. Make sure that to write the values of k on the top and the bottom of the sigma symbol. Now we can use the property 2 that is listed right here and factor out, so to speak, the coefficient in front of k squared and k in the first two sigma. So k in the first 4 from the first sigma can be factored out, and 4 from the second sigma can be factored out and written outside of sigma. So we'll have 4 the sigma from k equal 1 to 125 of k squared plus 4 the sum from k equal 1 to 125 k, and last term here is the sum of a constant. So we can use the first property listed here. The sum of a constant is that constant times the number of times it is added, and it is 125. Now we'll use the formulas for the special sums. The first formula is the sum of the 125 terms of the squares of the first of the positive integers. So this is the formula 2. Using that formula, we can rewrite the sum or evaluate the sum to be 4 times, this is the formula with n equal 125, so it's going to be 125 times 125 plus 1 times 2 times 125 plus 1, all of this divided by 6. The second term will use the formula for the sum of the first n terms of positive integers, and since n is equal to 125, that's going to be 125 times 125 plus 1 over 2. And then we'll add 125 from the last term. We can simplify whatever is we are able to simplify, and we can write the answer as 2 times 125 times 126 times 251 divided by 3. We add to that 2 times 125 times 126 and 125. Now we can use a calculator to find what that number really is.